Right. For our check-in, we had the two cars lining up. They had equal mass distribution, just so you know that they're like pretty much exactly the same car, and they were all legal and safe for racing. They started at the same time, but one car reached 60 miles an hour in 2.6 seconds, while the other car reached 60 miles an hour in 2.9 seconds. Which car developed the most power in the race? Remember, power is how fast you can spend energy. You know, like a weightlifter, you're trying to lift something and it takes you forever to do it, but you lift it. You did just as much work as somebody who lifted it real fast. But somebody that lifts that weight real fast had more power than you because they did more energy per second, more joules per second. That's what watts are, it's joules per second. Anyway, the one that did the most power is the one that got to 60 miles an hour in a faster time. They spent more energy per second, so they are the more powerful car. And I guess they won, or whatever. They're all fast cars. So. Anyway, today we're making sure we remember that elastic collisions business with all those 8 different variables and stuff. So, which one am I even doing right now? Is it this one? Okay. So, which color marker do y'all want? Purple, blue, black, blue? Blue. They picked blue last time. How about that? So, we got a 1.5 kilogram space banana. Space banana. Traveling at 6 meters per second. Speaking of space bananas, it's Double Tuesday today. We got 3 Double Tuesdays in a row to begin each of these first 3 weeks back.
What does that mean?
Well, there's no Mondays. Yeah. But you guys know the banana flavored candy and anything that's supposed to be banana flavored?
Yeah.
That doesn't really taste like bananas, right?
It tastes like medicine.
Do you guys know why that doesn't taste like bananas? Because they what?
It's synthetic.
Well, that's what I always thought. But it turns out that it actually matches the taste of the banana that in the 1960s went extinct. So the way they would grow the bananas is they would clone a banana plant. And so every banana plant being grown was a clone of that one plant. This was a French banana called the Gros Michel.
You know something else?
No offense, French. I just like to mess up the French accent. But it's a Gros Michel banana, Grosmichel. And excuse me. There was like a fungus or something that figured out how to infect one of those plants, and since they were all clones of each other, it figured out all the plants and they went extinct. But it tasted like that banana taste that's in the fake banana candy and whatever you got. I had like a banana Twinkie last night or something, and it reminded me of it. It's pretty cool. And now we have the Cavendish banana, which is like some kind of British name, I guess. And all of those bananas are also clones of each other, so it could happen again. But they know what happened last time, so they have fail safes, and they got some growing in Antarctica or something like that, where it'd be difficult for the fungus to spread, and then yeah. Anyway, so we got the 1.5 kilogram space banana. We don't know what kind of banana it is, except for a space banana. Traveling at 6 meters per second. That's our object 1. We got M1. It's 1.5. That's the mass of object 1. M2 is 6. That's the that's not M2. Come on. M1 is the mass. V1 is the velocity of object 1. 6 meters per second. It collides with a stationary 4 kilogram microasteroid. This is a very small asteroid. What was it? Mass 2 is 4 kilograms, okay. So it's not like a little rock, but it's small for an asteroid. And it's stationary, so V2, velocity of object 2, is 0 meters per second, I guess, whatever. And then finally it says, it doesn't say after the collision, but it does say the space banana leaves the collision, so that does happen after the collision. Space banana leaves collision with velocity of 2. That's that 1.5 kilogram space banana, which means that's mass 1. So afterwards, mass 2 is still 1.5, but it says it leaves a collision with this velocity of 2. So instead of 6, V2 will be a 2. Calculate the speed of the microasteroid after the collision. So our mass 2 is still 4 kilograms. We got to figure out what V2 is going to be for after. Alright, so I got the before side, M1 V1 plus M2 V2, and the after side, M1 V1 plus M2 V2. Alright, now I gotta plug everything in. So, see, you'll remember y'all have to do this before column and then the after column because everything M's and V's and 1's and 2's is confusing if you don't keep it organized. So my before column, on the before side, M1 is 1.5. V1 is 6. M2 is 4. That's a 4. And V2 is 0. After, M1 is still 1.5. Oh, I said M2s and stuff over there, man. It is a totally double Monday today. Okay, M1, V1. So mass 1 was 1.5, mass 1 is still 1.5. Velocity 1, though, is now 2. M2 is still 4, and velocity 2 is we don't know. We gotta figure it out. Remember, all that is 95% of the work you have to do for the question. It's just keeping everything organized and writing it in the right spot, because now it's real easy. 1.5 times 6. Oh man, I guess that's not super easy. What? 6 times 1 is 6. 6 times 2 is 12. So 6 times 1.5 will be halfway between 6 and 12, which would probably be 9, right? Also, you could say like 6 times 1 is 6, and 6 times 1/2 is 3, and 6 plus 3 is 9, right? Y'all paying attention here? Trying to get your brains working. I don't know, Gabby. It feels hot in here to me too. I think it's blowing on me. That's what happens. Anybody else hot?
No.
Anybody cold?
I mean, it feels fine now.
Mm.
I think it's just because you're under the vent that it's really hot right there.
Also, I'm flapping my arms around doing a problem up here. 4 times 0 is 0. 1.5 times 2, so another difficult one. That's 3, right? 2 times 1 is 2. 2 times 1/2 is 1. 2 plus 1 is 3. 4 times V2. I don't know. Alright, so this one isn't quite as simple. 9 plus 0 is 9, and now we have 3 plus 4 V2 over here. Remember, you can only add these. You can only say 7 V2 if this one says 3 V2 plus 4 V2. It's like 3x plus 4x because it's 7x. But 3 plus 4x, you can't combine those because they're not like terms. So what we got to do, eventually we're going to divide both sides by 4 to get the answer. But right now, we got to get rid of this 3. It says plus 3, so I'm subtracting 3 from both sides. That makes 0, so 0 plus 4v2 is just 4v2. 9 minus 3 is some kind of number, like a 6. And we want to get v2 by itself. It says v2 times 4, so now we divide both sides by 4. 6 divided by 4 is that 1.5 again? Everything's 1.5 in this one. 1.5, and that's a velocity, so it's in meters per second. Please go try that. Elastic collisions too.
Restroom time?
Double Tuesday.